Wrong one. Correct one. We've done part 2. Now we're doing part 3. You see this? Fun fact. This paper is working in progress. That means I haven't recognized it, but when I saw on the videos, I finally recognized it. Time to part 3. So, 2006. Last part was short, but this one, I don't know how long will it take. Alright, so in 2061, the Halley's Comet will return back. In 2116, Mars will start terraforming. 2117, Earth will get to 16 degrees Celsius. In 2178, Pluto will finish its first orbit of discovery. In 2250, Mars has been terraformed. In 2300, Voyager 1 finished its golden record to the Oort cloud. Working in progress will be now 2700. Venus will be terraformed, which I didn't draw it because I haven't done anything at all. 10,000 years. Both red supergiants, Antares and WOHG64, will finally explode in a supernova. 50,000 years. A red hypergiant star, VY Canis Majoris, will explode into a supernova in the 100,000 years. Many of today's constellations will not be seen. Hold on. In 1 million years, a red supergiant star, Betelgeuse, will explode in a supernova. And of course, 2 of Uranus's moons will collide, and the planets cannot catch a break. 25 million years, an orange main sequence star, possibly more closer than Proxima Centauri will be from the Sun, is 0.2 light years away. 50 million years. In 50 million years, Mars's moon Phobos is on a rocky limit, becoming broken on Mars. So Mars will get its own ring, but suddenly 100 million years. As Mars gains a ring, Saturn slowly loses them. Well, that's so sad. 600 million years, the final total solar eclipse. I didn't draw what will happen in 800 million years because I forgot. But in that amount of time, the sun will become 1 times brighter, becoming a yellow subgiant. 1.1 billion years, Sun will become an orange giant as 10 times brighter. But on the bright side, you put up a good fight, because Mars will enter habitable zone and could provide life and be terraformed like last time. But 4 billion years, both spiral galaxies, the Milky Way and Andromeda, collide together. 5 billion years, the Sun will turn into a red giant, making Mars uninhabitable. But on the bright side, 6 billion years, the Sun will enter its red clumps and enter its AGB state, and Jupiter's moons, Europa and Ganymede, will become habitable. In terminal pulsations, 7 billion years, another sponsored video like from part 1, the Sun will turn into a blue giant just because of my pocket galaxy, the normal version or the full version. Remember what I told you last time? You can just name your system, nebula, or galaxy anything you want. So you have every. So if you have every single of the My Pocket Galaxy, well, you're lucky because I don't have all of them yet. So to get a red giant, collide 2 stars together, and to get a red giant, collide 1 red giant into the other, and it will say, oh, never mind. I think placing another red giant and the other one will make a blue giant. Now a collision with a blue giant makes it will go to its final state called the tiny white dwarf. Hold on. White dwarf state? Alright. You can get its decayed state if you want. And let's go back to the video. So we have done this, and the Sun has turned into a blue giant, making one of Saturn's moons, Titan, habitable. 8 billion years, the Sun enters its final state and sheds its outer layers, forming a planetary nebula, leaving behind a white dwarf. This could be any star in the universe, except for neutron stars. Or can it? Huh? All red giants turn into blue giants and then planetary nebulas, leaving behind white dwarfs. 500 billion years later, plus 50 of the local group galaxies merge. 1 trillion years. Oh, come on, I hate this. In 1 trillion years, radiation left over from the Big Bang would become undetectable. Hello there. 10 trillion years, red dwarfs become blue dwarfs. 1 quadrillion years, the sun will become 0 degrees Celsius as it became a black dwarf. That's all for part 3. See you in part 4. Up and up and up and away!